Okay, so my intention for this video is just to kind of show you some differences in features on parts, the same parts. One was printed up and one was printed down. So they were in the print bed like this. And I wanted to show you on this machine, and I think this is pretty common across SLS machines and orientation, but I did want to share this with you. And then I have some other info I'm going to share with you on some tensile testing as well that I did. Now, on every print job I do, I always print a couple of my tensile bar tests, and then I test those on the tensile tester I built, and you saw in my previous video. And then that kind of gives me an idea of what I'm looking at in terms of what the tensile strength of these parts should be. So, all right, so let's take a look at what I discovered. Now I'm going to show you both in video and then in close-up pictures that I took, which may show this a little bit better. But first of all, I want to show you, I got this part off of Thingiverse by, his name was Tech Tutor out of Poland, but I liked it because it just had inner and outer diameters I can measure, had a little tolerance lever test here. Some of these tests don't apply, but it had some good lettering and numbers as well to show you. So first of all, let's just talk about overall appearance. All right, so you'll notice on these that one of these has sharper letters and numbers. So if you can see, I'll show also, this is the video, and we can move in a little bit closer, but you'll see that this one, the letters are quite sharp on both the numbers and letters. You can see up there on the levers. All right, so this one was printed face up. And so what you find is when you print parts face up, when it comes to details on letters and numbers and those sort of things, they tend to have sharper details. Also, and I'll show this also in the picture as well, but I don't know if you can tell, but this surface, it actually looks a little lighter than this one, but it's smoother, so face up. So when you print things in SLS, when you print up, side up tends to be smoother. And so that's the difference. And if you flip them over, you can see that this has more of a grainier surface than this one, because this was obviously printed, this side is up. So that's the first thing in terms of appearance. Let's talk about the diameters. So both of these, they have a set of posts here, and then just a set of holes. And so these are 4, 6, 8, and 10 millimeter width post, and the same goes for the inner diameter. So this is the piece that was printed face up. And if you measure these, which I did with the calipers, and I'll show you those results here right next to it, you'll see that the outside diameters on this were really spot on. I mean, I averaged 0.03 millimeter difference. So, I mean, 1/1000th of an inch, right? And then the inner diameters, they tend to be undersized. I see this just very common. And you can see it's just a little undersized by under 0.3 millimeters. So that's one of the reasons why the best gap you can tend to maintain with SLS is around 0.3. And in this case, speaking of that, you can see I was able to pretty much got this to move by just holding that lever and pulling it, and it was able to break loose. And that one moves freely. Of course, I couldn't do the 0.2. So that kind of gives you an idea in terms of dimensions. So this is the part that was printed face up. Now this part, first of all, we'll look at these numbers again. You can see the numbers and letters, they tend to be more rounder, actually smoother. So it takes away some of that sharpness. And in some cases, the detail is actually better. Like if I show you this 0.15 here, by it being smoothed out, it's actually, you can actually see it better than you can on this one, where it's it's sharp on the outside, but it got kind of meshed in the inside. So face down, The letterings tends to be more rounded and smoother in terms, but the overall surface, as we saw, was slightly grainier. Now, when we look at the dimensions on this, so once again, I'll show the overlay there, and you can see that the outside dimension of these actually were slightly undersized by about 0.1 millimeters, and the inner diameters were about the same as the one that was printed face up. So dimensionally, face up seemed to actually, dimensionally, I thought overall was better, and but I still, inside diameters are still tend to be undersized. So that would, in your design, have to think about making those slightly larger to allow for that. All right. Oh, the density of these as well. So the part density, based on the model volume and the weight of these, they both were around close to 0.97. So slightly under what I expected. And I didn't tell you, I printed these at 85% of the laser energy density, which is where I seem to be settled where I like to be at. But they're slightly, usually I see running around 85%. I'm seeing about 98.98 of the part density. And when I went back and looked, I did forget to clean the window between the laser and the print bed. I mean, it wasn't, I wouldn't call it foggy, but at all, but it just slightly. And so that could have been the difference. Also, the tensile bars that I printed in this, you see I did a total of, I believe, 7. 4 in one direction, 4 in the Y direction, 4 in the X direction, and they pretty much all measured. They average about 42 megapascals. So I would expect that with the density. That's about usually where the tensile strength finishes up at. So that in terms of part density and strength, and then like I said, on the part tolerances on this one that was printed face up, I got to move freely, pretty easily, with a little pressure on this lever, and it broke free. And on this one, when I did the lever, it broke off by hand, and then I took some pliers and was able to break that free. So there's still some tolerance there. It just took a little extra motivation, you could say. So what the conclusions? Well, orientation matters, obviously, and it depends on what you're trying to do. So if you're trying to get very sharp details and dimensions, you want to think about printing face up. If you're looking at more rounded, maybe rounded or smoother surfaces, putting that part face down. And the other thing, we haven't talked about this, but we don't see layer lines in these at all, and which is a good thing. This means this thing prints very, very fine at 0.1 millimeter levels, but also how you orient this in the bed could show layer lines as well on your surface. So keep that in mind when you print. There is one thing I do want to note. I printed some of my tensile bars a couple weeks ago using the 100% energy density, and it averaged about 46 megapascals using the 100% laser density, except one of them did not. And when I went back to look at how it packed it, normally I have it set these to set in the X and Y direction, but one of them I didn't have set, and it actually was in the print bed at an angle like this. It was actually turned slightly and slightly in the bed in the Z direction, and that would make sense. Even though it's a lot stronger in the Z direction than FDM, I saw, as you can see from the chart here, in that particular example using the 100% energy density, when one was slightly in, I saw about a 5 to 6% difference in tensile strength. So that matters too, as well as how your part's oriented. And you're going to see if it's slightly in the Z direction, you're probably going to have a drop off in your strength of your part. So if that's important to you, you need to make sure you orient your part to get the maximum amount of strength. So with that said, just a real quick video to kind of show you how you orient your parts in the print bed. It can make a difference both dimensionally, both in terms of visually, and so that's important. So, all right, stay tuned for the next video. I have no idea what it will be, but as I move along with this and I come across things, opportunity for me to present it to you. Have a great day.